Hello friends, welcome once again to Edupedia Word Videos, Virtual Word Free Education. In this video, we'll be learning how to solve a pair of linear equations graphically. Friends, if we have a line, say L1, then this line is a collection of points located consecutively and closely. All these points lie on the line. Thus, all these points are solution of line L1, whereas this particular point where the line cuts x-axis is known as 0 of the line. Similarly, for a line L2, the location of points can be like this. All these points again are solution of L2. If we join these two lines on a single graph, then the graph will be like this. This particular point is falling on both the lines L1 and L2. Thus, this point is the solution of both the lines L1 and L2. Therefore, solution of the given pair. Friends, we can have different type of lines as intersecting lines, a parallel pair, or a coincident pair. In this case, this particular point is the only point which is falling on both the lines. Thus, it has one solution, P. Parallel lines never intersect, therefore no case of common point arise. Thus, parallel lines have no solution, whereas the coincident pair always lie on each other. Thus they have many, or we can say infinite number of solutions. Friends, there are some steps involved in finding the solution of a given pair of linear equations graphically. The first step is to plot the equations of both the lines on a single graph. Then, solution is the point where both the lines meet each other. That is, we have to find out the point common to both the lines. That particular point will be the solution of the given pair. Let us study graphical method with an example. X plus y minus 10 equal to 0 and x minus y plus 4 equal to 0 be the given pair. Friends, the first step says plot the given pair graphically, for which we have to find out a set of values for different values of x and y. Friends, for the first equation, if x equal to 0, we have y minus 10 equal to 0 or y equals 10. Whereas if y equal to 0, we have x minus 10 equal to 0 or x equal to 10. For the second case, if x equal to 0, we have minus y plus 4 equal to 0, which means y equal to 4. Or if y equal to 0, we have x plus 4 equal to 0 or x equal to minus 4. Thus, the second step, we need to plot the graph and find out a common point. We are using the distance between points to consecutive points as 2 units. For equation 1, if x equal to 0, y is 10, and if y equal to 0, x is 10. Thus these 2 points will lie on first line. Joining these 2 points, we get the curve of first line like this. For the second equation, if x equal to 0, y is 4, whereas if y equal to 0, x is minus 4. Thus joining these 2 points, the equation of line has this curve. Now this particular point lies on both the on both the equations. Thus the point P is the solution of given pair. If we plot this equations on a standard graph, we will find that this point is 3, 7. Thus graphically, the solution of this particular pair of lines is 3, 7. Friends, we have studied in the graph that this pair has intersecting lines and thus exactly one unique solution. Such kind of pair is known as a consistent pair. Moreover, the coefficients of x, that is 1 over 1, their ratio, is not equal to the ratio of coefficients of y, which is 1 over minus 1, that is minus 1. Thus, if we need to check whether the lines are intersecting or not, just look at the coefficients of x and y. If the ratio are not equal, then the pair of lines will be intersecting. Let us have another example to study graphical solution of equations. 6x minus 3y plus 10 equal to 0 and 2x minus y plus 9 equal to 0. Six x minus 3y plus 10 equal to 0, 2x minus y plus 9 equal to 0. Labeling the equations as 1 and 2. For the first equation, the table of different values of x and y will be, if x equal to 0, we have minus 3y plus 10 equal to 0, or y equal to 10 over 3, which is nothing but 3.33. If y equal to 0, we have 6x plus 10 equal to 0, or x equal to minus 10 over 6, which is minus 1.66. For the second equation, if x equal to 0, we have minus y plus 9 equal to 0, or y equal to 9. Whereas if y equal to 0, we have 2x plus 9 equal to 0, that is x equal to minus 4.5. Now plotting the given pair on a graph. For the first equation, if x equal to 0, we have y as 3.33 somewhere over here. Whereas if y equal to 0, x is 1.66. Thus joining the 2 points, the line goes like this. For second equation, if x equal to 0, y is 9, and if y equal to 0, x is 4.5, minus of 4.5. Thus joining these 2 points, friends, if we plot these two equations on a standard graph, we will clearly find that these two pair of lines are parallel pairs. Thus, no question of a common point arise. Thus, they have no solution. So, for a parallel pair of lines, we have no solution. That is, lines are parallel and we have no solution. Such a pair is known as an inconsistent pair. If we examine the coefficients here, we will find that 6 over 2 is 3, minus 3 of minus 1 is again 3, whereas 10 over 9 is not equal to 3. Thus, for parallel lines, a1 over a2 equals b1 over b2, not equal to c1 over c2. Let us have one more example. 9x plus 3y plus 12 equal to 0 and 18x plus 6y plus 24 equal to 0. For the given equations, for equation 1, if x equal to 0, we have 3y plus 12 equal to 0, or y equals minus 12 over 3, which is minus 4. If y equal to 0, we have 9x plus 12 equal to 0. That is, x equal to minus 12 over 9, which is minus 4 over 3, or minus 1.33. For the second equation, if x equal to 0, we have 6y plus 24 equal to 0, or y equal to minus 24 over 6, which is minus of 4. Whereas if y equal to 0, we have 18x plus 24 equal to 0. That is, x equal to minus 24 over 18, which is minus 4 over 3, which is again minus 1.33. Plotting the graph, For x equal to 0, y is minus 4. For y equal to 0, x is minus 1.33. Joining these 2 points, the curve of first equation is like this. Friends, similarly for the second equation also, the points are 0, minus 4 and minus 1.33, 0. Thus, the given pair of lines fall or lie on each other, because the second equation also has the points as the first equation. Therefore, here we have infinite number of solutions. Thus, lines are coincident here and we have many solutions. Such a pair is known as dependent and consistent pair. If we examine the coefficients and constant term, we will find that 9 over 18 equals 1 by 2, 3 by 6 is again 1 by 2, and 12 by 24 is also 1 by 2. That is, the coefficients for coincident lines are equal in ratio. Thus, there are 3 types of graphical solutions named as consistent, inconsistent, and dependent as well as consistent. Here's a tabular representation of what we have studied so far. If the lines are intersecting, then the coefficients of x and y are not equal in ratio, and we have exactly one solution. If the lines are coincident, then the ratio of coefficients is equal and is also equal to the ratio of constant term, and we have many solutions. If the ratio of coefficients are equal but not equal to the ratio of constant terms, the lines are parallel and we have no solution. So friends, that was all about how to deal graphically with the pair of linear equations. Thanks friends for watching Edupedia word videos.